On October 24th, 79 AD at 1 p.m., one of the most famous natural disasters in history struck Pompeii and the surrounding towns. Vesuvius, a volcano in the south of Italy, erupted, unleashing its incredible and hitherto unknown power.
Within just a few moments, just a few hours, it was apocalyptic.
A volcanic eruption, in a way, is comparable with energy to a nuclear explosion.
In less than 24 hours, the eruption of Mount Vesuvius erased several towns from the map, including Pompeii and Herculaneum. Thousands of people perished in horrifying circumstances.
The heat was such that it literally boiled their brains, and the intracranial pressure led the skull to fracture and explode.
Buildings and people were buried by mountains of ash and pumice stone from the volcano. As incredible as it may seem, this terrible fate preserved the city. And 2,000 years later, scientists who continue to dig amongst the ruins have unique access to an exceptional source of information concerning this natural disaster.
The eruption Pompeii is probably one of the best studied eruptions in the story of the volcanology.
For the first time, volcanologists will show us sites still unknown to the general public and which reveal new information about the eruption. When we look at these deposits, we can see that they have buried this entire area under tens of meters of ash and pumice. Thanks to the results of research in forensic medicine and their staggering revelations concerning this human tragedy, we will discover the terrible circumstances of the deaths of the victims of this natural disaster.
This is an exceptional discovery. Here we have 2 vitrified brain fragments. Fragments like these had never been seen before.
Join us as we reconstruct the final moments of the lives of those living in Pompeii, minute by minute, with the help of fictional characters inspired by the knowledge of our experts.
The advantage of studying Pompeii is that we're not just looking at death. We also look at life, the life of an entire town.
Who were they? And what was their tragic fate? Could the townspeople have escaped?
There was no way out. They'd missed their chance to escape.
And above all, could such a catastrophe ever happen again?
This volcano is one of the most dangerous because of the high density of population in the area.
In any case, one must prepare for the worst.
Using information revealed by the vestiges of the eruption, the knowledge of international experts, unique examples of life at the time, as well as analysis of CGI images, immerse yourself in the final hours of Pompeii as though you were really living them. In Pompeii, amongst the beautifully preserved ruins which have made this town famous, the figures of those who lived here, frozen in time, are a reminder of the tragedy that took place. On October 24th, 79 AD, it's estimated that more than 1,500 people perished here, victims of the volcano's power. Their bodies represent one of the most famous and violent volcanic eruptions in history.
We don't label these bodies as individuals. We label them as victims, which designates them more precisely as victims of a historical natural disaster.
Pompeii and Herculaneum are both cities located within a few kilometers of Vesuvius, the volcano that overlooks the Bay of Naples. And it was certainly no accident that such a catastrophe occurred in this part of southern Italy. Those living here have faced continual threat from volcanoes for thousands of years. 200 kilometers to the south is Stromboli, and a little further on, you'll find Etna. Today, these volcanoes are famous for their regular and spectacular eruptions, but they were already highly active at the time of the Pompeii disaster. Vesuvius has erupted many times throughout the centuries, most recently in 1944. How could the people of Pompeii have been so unaware of the activity of the volcano that overlooked their city nearly 2,000 years ago? What if these figures could tell us about those final tragic hours in Pompeii? This is a blow-by-blow account of that terrible day in the fall of the year 79 through the eyes of 2 people. Julia, a fictional Pompeii local and a rich woman, who was there when the eruption began. And Pliny the Younger, a very real historical figure who lived outside of the volcano's destruction zone. He is the only witness to have written down his observations of the disaster in 2 letters, which are considered today to be extremely historically important.
Modern volcanology has taken his description of a volcano's eruption as its starting point. It was the first time so much detail had been recorded about an eruption from beginning to end. When it happened, what it looked like, how it unfolded, and how it ended. These letters are an almost minute-by-minute account of what took place.
The letter of Pliny the Younger were so important all over the world that the volcanologists gave the name of this kind of big eruption, Plinian eruption. And we are still using these letters to check which kind of event happened at what time. So each line is very important.
Let's go back in time. It's 9 a.m. on the morning of October 24th, 79 AD. At the time, Pompeii was a bustling provincial city within the Roman Empire, bordering the Mediterranean coastline 20 or so kilometers from Naples. It was ideally located, thanks to the surrounding, particularly fertile lands and the intense commercial transport activities in the bay. Both helped the town to prosper.
Pompeii was a rich town of 20,000 people. I imagine this town as a very dynamic, noisy town. There were beautiful houses, businessmen and people that had a vineyard on the slopes of the volcano.
This is an environment that was very conducive to life. The volcanic ash nourished the soil, which meant it was much easier to farm crops. The Mediterranean climate was also a huge advantage.
Julia is 42, a rich widow with many years of experience running her own business. She lives in one of the big, beautiful houses in the noisy, bustling town center, an especially good place to live. For her, life is good, and the mountain overlooking the town is of no concern.
They didn't know that Vesuvius was a volcano. To them, Vesuvius was a beautiful mountain, teeming with life, flowers, trees. So they didn't know what was coming.
But Vesuvius is anything but a peaceful mountainside. It's a volcano. Several kilometers under its summit, magma, molten rock that can reach temperatures of up to 1,000 degrees Celsius, was collecting in an underground chamber. Under pressure, the magma pushed its way towards the surface, up through what's known as the volcanic pipe, or conduit. If the magma is runny, there is a low concentration of gas, and the pipe is open, it comes out in what's known as a lava flow. This is called an effusive eruption. If the magma has a very high gas concentration and the pipe is closed, then it explodes outwards instead, in what's called an explosive eruption. The magma is projected skywards for hours, and so powerfully that a huge vertical pillar of volcanic ash is created, known as an eruption column. This is what happened in 79 AD. But volcanoes can alternate between effusive and eruptive phases, which was precisely what happened with Vesuvius.
The characteristic shape of Vesuvius as we know it today was created after the eruption in 79 AD. At the time, it looked very different to what we see now.
Between the eruption in 79 AD and today, the volcano has gone through many effusive phases, especially in the 18th and 19th centuries. As these eruptions have occurred, lava has accumulated around the volcano, gradually giving it this very recognizable cone shape.
The volcano at the time had a shape like our panettone, Christmas panettone, a mountain with a flat top.
Pompeii's inhabitants seem to have been completely unaware of the danger. They didn't understand the gradually more serious signals the mountain had been proffering them for years.
It seems that the eruption of Pompeii hit the people as a big surprise, but actually, these people experience all the big signals that we should expect when there is an eruption.
We know that 17 years earlier, in 62 AD, there was a big earthquake felt by the whole population and which caused damage around Vesuvius. Today, such an earthquake would be the first sign to alert us to the fact that magma was beginning to rise into the Earth's crust.
When the magma rises towards the surface, it puts a phenomenally powerful amount of pressure on the walls of the magma chamber, creating fractures in the rock. It also makes the volcano swell, so much so that sometimes it's possible to notice the top rise by tens of centimeters. These big changes in the volcano structure provoke violent tremors, which lead to earthquakes that can be felt throughout the area.
There were certainly many other earthquakes leading up to the year 79 AD. And in fact, we have proof, because inside the houses, you can see many attempts to rebuild, made because the houses were constantly being damaged by these regular quakes.
Several other signs of abnormal activity occurred in the years before the eruption.
There were also gas emissions, with cattle dying of asphyxiation because of the gases coming out of the volcano. Frankly, that's the sort of thing you definitely notice.
And as October 24th approached, the town's fountains dried up. The magma was swelling so much underground that it changed the gradient of the aqueducts supplying the town.
Just before the eruption, the people didn't have water because of the inflation of the ground. All the aqueduct stopped to send water.
It's 10 o'clock in the morning, 3 hours before the eruption, and the signs are becoming more and more obvious, with an increased frequency in earthquakes. Pliny the Younger is on the other side of the bay at Mycenae. The 17-year-old son of the admiral of the Roman fleet spent his days studying. He didn't understand the imminent danger any more than Julia did.
For several days, we had been feeling some precursory earthquakes, which no one worried much about because they were not unusual.
Around midday, just 1 hour before disaster struck, the sound of thunder rumbled loudly from the mountain. Just like the other people in Pompeii, Julia wonders what's happening. What they don't know is that in getting closer to the surface, the magma has made contact with the phreatic zone and infiltrated it several hundred meters under the mountain. When it comes into contact with magma, the water transforms into scalding steam that's several hundred degrees Celsius in temperature, and its volume is suddenly increased. The pressure is so huge in the volcanic pipe that it pulverizes the remaining rocks blocking the way, creating loud blasts which can be heard from several miles away. A cloud of ash is then ejected from the volcanic pipe and rises several miles into the air before falling rapidly back to Earth.
It lasts 10 minutes or so, and it's this opening of the pipe that then allows huge quantities of magma to spill out over the surface.
Let's head now to the village of Terzigano, 4 kilometers southeast of the crater, to a unique location, an old quarry where we can see visible proof of how the pipe opened. As the quarry has been exploited, it has revealed some impressive cross-sections in the rock deposits from the volcano's eruption. For volcanologists tirelessly searching for and analyzing remnants of the eruption, it's a real gold mine.
I've come here many times with my assistants. We've worked for weeks in this quarry, studying layer after layer, taking many samples, and studying the eruption sequence of events as a whole.
This quarry is a well-kept secret amongst volcanologists. This is the first time it's being shown to the general public. It is a site that reveals the true extent of the violence of the eruption.
Thanks to this quarry, we know the exact order of events of 79 AD. If we examine these deposits, we can see that they buried this entire zone in tens of meters of ash and pumice, meaning that, before the eruption, so 2,000 years ago, this landscape looked totally different.
In this way, we can work out what happened an hour before the eruption. Under the meters of gray deposits left by the volcano, we find a darker color, the ground of the day of the eruption.
It was on this surface that the Romans walked and moved around the volcano 2,000 years ago.
And just above this level, there's a smaller layer of ash which might seem unimportant, but which is in fact fundamental, as it shows us that the volcano's conduit had opened.
The eruption started off fairly calmly, because this cloud of ash, which rose up several miles into the sky, quickly collapsed. The gases and ash spread out, falling over the ground. And as the ash accumulated, it turned to sediment.
Julia and the people of Pompeii watch as the gray cloud appears in the fall sky, but they never imagined the tragedy that was about to unfold.
One might ask, what's going on? Is there a storm coming? Because there are rumblings from afar, and the sky is darkening. We have found only this layer on the slopes of the volcano, maximum 5 kilometers from the volcano, which means that all the people and towns which were beyond that, like Herculaneum and Pompeii, never felt the effects of this event. From afar, all they saw was a pillar of ash rising and spreading out around the volcano. But was it enough for them to think, we should leave? Something's going on. I think my life is in danger. Maybe not, because it was happening far away. But maybe those who left at that moment made the right choice.
According to Pliny's letters, it was around 1 p.m. when the volcano erupted. The roar of the eruption reached the ears of Pompeians 24 seconds later, once the sound had traveled the 8-kilometer distance between the town and Vesuvius. Just as we see lightning before we hear the thunder. A similar eruption was filmed taking place several years ago at the Tvorvor volcano in Papua New Guinea. Even though it was a much less powerful eruption, these images show the forces at play during such a phenomenon.
Watch out for the shock, it's coming.
When an eruption begins, there's this almost instantaneous release of energy which creates a shockwave, like a sort of bubble that spreads out, heading straight towards you. So it's very disturbing. It's very probable that the inhabitants of Pompeii and other towns heard that.
How do we analyze these exceptional forces at play? Matteo Serminara studies the simulation of volcanic eruptions, and he has reproduced the eruption that occurred in 79 AD.
A volcanic eruption, in a way, is comparable with energy to a nuclear explosion, okay? And also visually, you can see that it's a mushroom, no? It seems a nuclear explosion. The energy that Vesuvius 79 produced and injected in the atmosphere is tens of megatons. So it's more or less 1,000 times the energy that was released in the atmosphere by the Hiroshima nuclear bomb. That was more or less 15 kilotons. Of course, this energy has been released by Vesuvius on a much longer time period, 20 hours, while a nuclear bomb is able to release a lot of energy in a very short amount of time.
Right after the explosion, dark smoke began to rise into the sky at a terrifying speed of 700 kilometers per hour. 3 minutes later, this pillar of ash had reached 20 kilometers in height. Thanks to a digital simulation, we can easily analyze its rapid ascent.
So if you want now to have a look a little bit more in detail, we can cut the numerical simulation with a slice. And instead of looking at the edges of the plume, of the volcanic column, we can have a look inside.
This cross-section shows that at the crater's exit, the burning mix of magma and gas, here in red, bursts out of the volcanic pipe under huge pressure. It's projected at speeds of several meters per second, allowing it to quickly reach an altitude of 3 to 5 kilometers. At this point, another phenomenon takes place. The hot matter mixes with the air around it, creating a huge cloud that reaches extreme temperatures close to 800 degrees Celsius. Since it's much lighter than the gases in the atmosphere around it, it quickly rises into the sky.
So, in reality, what makes the plume rise tens of kilometers is the temperature. And it's not intuitive, but the higher velocity are reached in this part. We are speaking of velocities of the order of 1,500 kilometers per hour. That is more than Mach 1. You are supersonic. So any parameter in a volcanic eruption is extreme. Temperature, velocity, everything.
This menacing cloud then begins to float southeast over Pompeii, raining down some of the volcanic matter contained within it as it's transported. Little stones start to rain down around Giulia.
There are different elements within the pillar of ash. There's a bit of everything, really. What I mean is the magma has been pulverized and the lightest elements are projected the furthest, blown furthest by the wind. And these are ash particles measuring less than 2 millimeters, and between 2 and 6 millimeters are what's known as lapilli.
The lapilli that fell on Pompeii were formed in the volcanic pipe, which rises out of the magma chamber, 8 kilometers below the surface. The difference in pressure between the inside of the chamber and the outside of the volcano makes the magma rise towards the surface and creates more and more bubbles within it as it rises. Around 2 kilometers from the exit, there's so much gas that an explosion occurs, projecting the magma upwards and outwards. The shock is enough to break up the magma into fragments of different sizes. Once in the sky, these fragments solidify into pumice stone, rocks full of tiny holes, which are therefore very light. In Pompeii, these pumice stone fragments are called lapilli, reflecting their size. When they fall to the ground, the lapilli are still not completely cool and can reach temperatures of more than 100 degrees Celsius.
Pompeii received a rain form of lapilli of pumice. The size was around 3 centimeters, more or less. You can imagine what kind of rain it was.
Giulia immediately runs into her house. Like all those living in Pompeii, she needs to find shelter if she is to survive. 2,000 years later, thanks to the appearance and visibility of lapilli in the quarry, volcanologists can retrace the events of the disaster almost minute by minute.
The higher the column, the greater the energy released, and therefore the bigger the fragments of pumice stone transported. Inversely, if the column is not very high, there's less energy, and the pumice stones that are displaced are smaller.
A quarter of an hour after the eruption begins, the pillar of ash is already higher than any airline flight path today, at more than 10 kilometers above the ground. The ash collides with high-altitude winds, which unfortunately on that day were blowing towards the town of Pompeii.
So when the plume reaches its maximum height, that is around 25-30 kilometers in this simulation, it starts to create the umbrella cloud that we see here, okay, all around the volcanic plume. These umbrella clouds develops in the direction of the wind.
Unfortunately for Pompeii, it was one of the most affected areas. Whereas, if you look on the other side, on the north side of the volcano, modern-day Naples, there was no ash, even though some areas are actually even closer to the volcano.
It's been half an hour since the eruption began. From Mycenae, 25 kilometers west of Vesuvius, Pliny has the perfect view of the volcanic cloud. He's not close enough for anything to fall on him, and he has the uninhibited view of the entire bay.
A cloud was forming in the shape of a tree. very much like that of a stone pine, because it rose up very high like a tree trunk before spreading out in branches.
The lapilli have been falling continuously on Pompeii now for 4 hours, covering the town in a thick layer of pumice stone. It's difficult to imagine it today since all the roads have since been cleared. But when you visit an archaeological dig in progress, you can see there are lapilli everywhere.
The lapilli fell at a rate of 15 centimeters per hour. So after 1 hour, there was 15 centimeters on the ground. After 2 hours, 30 centimeters. And after 4 hours, 60 centimeters. So very quickly, not only the roofs, but the roads were full of lapilli, and it became very difficult to open any doors.
Like others living in Pompeii, Giulia is now stuck inside her home. She has no choice but to wait, sheltering inside.
Here you have a map that is evolving over time that shows you the thickness of the deposit in different locations. When you see a red color, this means that the deposit is reaching a level around 1,000 kilograms per square meter. That means that you have a deposit that is 1 meter thick. So the situation in Pompeii became very dangerous because the roof has to support a ton for every square meter.
In Pompeii, the timber roof structures with their tile rooftops start to show signs of degradation. Every minute that passes, the danger increases.
The roofs caved in. The tiles and the beams collapsed. Here's a good example. We can see the fallen tiles and collapsed roof amongst the pumice stone. You can also see other structures that collapsed at the same time as the roofs. It's quite clear that anyone sheltering here would have been buried alive under the weight of the fallen buildings.
According to Claudio Scapardi's findings, 360 people, that's 38% of the victims of this natural disaster, died this way. Around 6 p.m., Giulia's roof collapses, burying her under the rubble and lapilli. Seven hours after the volcano first erupted, Pompeii is already in ruins. And yet, the volcano has so far only offered a tiny taste of its destructive potential.
At the end of this phase, something completely new happens inside the volcano. While the eruption is still in progress, the pillar is supported, but a part of it collapses, creating a pyroclastic current which travels all the way to the coast. It reaches Herculaneum, bringing with it huge destruction.
These pyroclastic currents are one of the biggest dangers of eruptions. Burning clouds of gas, ash, and volcanic matter hurtle down the slopes of the volcano at speeds which can reach several hundred kilometers per hour, spreading death and destruction as they travel.
So when we think about pyroclastic current, we have to think about the strongest wind that we experience in our life. So we have like a huge hurricane, a huge cloud full of material at the base that kill you because of the shock, the impact, because of the high temperature. In any case, it's not possible to survive.
Until that point, Herculaneum had been a charming town of 4,000 people, located 6 kilometers west of the volcano, which had been lucky enough to escape the falling lapilli. But it was not so lucky during the second phase. Pier Paolo Petrone has taken part in many archaeological digs at Herculaneum and has seen the destruction caused by the volcano with his own eyes.
At the start of the 1980s and into the 1990s, hundreds of victims were found in a series of what are known as boathouses along the beach, as well as on the beach itself. This is a map of the beach as it was then. This was the sea, this is the beach, and these are the 12 boathouses in which the victims were found, as well as on the beach. So we can see that people huddled together in these boathouses to find shelter. There were so many people in some of them that not everybody could fit inside.
But what made these men, women, and children seek refuge in these fishing boat houses, which subsequently became their graves?
These boathouses, which led out to the sea, were the safest place, they believe, where earthquakes were concerned. Because at the start of the eruption, there were a few earthquakes. They didn't know what an eruption was. Here we can see a young adult leaning against the stone. He's sitting down, not moving, displaying no conscious reaction. Even the child who is lying down has contracted his hand against the heat, but he does not move. What this shows is that the temperature was so elevated that it stopped all the victims' vital signs. And so here we see the very last moment of these people's lives. No one had time to react. It was a painless death.
Having painstakingly recorded the position of each of the victims' bodies, Pier Paolo Patrone studied their bones, skulls, and teeth in great detail. Today, these remains are carefully archived in his research lab. They continue to help scientists learn much more about the characteristics of the pyroclastic current.
The Herculaneum skeletons are very important because every part of the skeleton, the skull, the long bones, arm and leg bones, clearly reveal the effects of the heat. Many individual skulls actually exploded because their brains were actually boiled. Their skulls were fractured because of the heat. In other words, the heat cooked their brains, and the intracranial pressure led the skull to fracture and explode.
A fratturarsi e esplodere. Qui abbiamo un esempio.
Here is an example of a child.
Di questo bambino, questo è il cranio di un bambino.
This is a child's skull, which has been totally fractured and blackened by the heat. What's interesting is that the ash, which was still hot and liquid, made its way into the skull and created this mold of the brain.
Another factor which demonstrates the effects of the extreme heat is the red color you see on the bones.
The very high temperatures quickly vaporized all the body tissue, and at that point, anything which might constitute blood residue or bodily fluids evaporated, leaving a red stain on the surface of the ash deposits on the bones.
These physical effects are, however, not enough to give a precise estimation of the temperature of the current, which led to so many deaths in Herculaneum. Which is why Pier Paolo Patrone took his investigations even further.
Years ago, we did an experiment on human and animal bones exposed to temperatures from 100 to 800 degrees Celsius. When we compared this color with the results of the experiment, we were able to say that the temperature the victims were exposed to at Herculaneum was at least 500 degrees Celsius.
A recent discovery has allowed him to reach some even more surprising conclusions.
This is a unique discovery. Here are two vitrified skull fragments. Fragments like this had never been seen before, and when I saw them, even I was taken aback. Very recently, we conducted an experiment on these fragments, and we concluded that the temperature at which a brain becomes vitrified is at least 550 degrees Celsius, likely more. But since we know that to achieve vitrification, you need a much higher temperature, this means that we're somewhere on the scale of 500 to 700 degrees Celsius. It's the first time we've been able to confirm such a high temperature for the eruption of 79 AD.
This death wave may have killed around 400 people in the town, But it was not the end of Vesuvius's destructive forces on Herculaneum. There were more currents to come.
Within just a few hours, this coastal town was completely submerged under different pyroclastic currents. One after the other, they continued to suffocate the town under 20 meters of debris and move its coastline by nearly 40 meters in just a few hours. A radical physiological transformation.
13 hours after the start of the eruption, Pompeii may so far have escaped the destructive pyroclastic currents, but the town is nevertheless plunged into chaos. A huge number of collapsed roofs are reflected in the lightning of the volcanic storm. By some miracle, some signs of life emerge from the destruction. Julia is one of the several hundred survivors whose houses remain only partially collapsed. At this stage of the eruption, the volcano has reached its maximum potential. Every second it projects more than 100,000 tons of magma into the air. And today, thanks to simulations, we know that the pillar of ash reached a height of 40 kilometers. 15 hours after the start of the disaster, to the west of the bay, Pliny the Younger is still able to observe events from a safe distance. But according to his letters, he had realized the earthquakes were increasing in intensity.
The houses had been so rocked by the many earthquakes that it looked like they had been torn from their foundations, thrown about from one side to the other, and then set back down again.
What does it mean? That we had the withdrawal of a huge quantity of magma, and now the explosion level went down in the magma chamber. We start to have destabilization of the whole structure, and the beginning of this destabilization was marked by these strong earthquakes.
These significant changes taking place within the volcano structure can be seen in the debris that fell on the town. In this area, which is still being analyzed, we can see the only cross-section of the deposits from the eruption still intact and visible today.
The layer of black rock tells us the volcano was becoming unstable. The lapilli are completely different. There are no longer light fragments of pumice stone like those which fell during the Plinian phase. Instead, they are heavy fragments like these, fragments of lava. They are pieces of the volcanic pipe which collapsed within the magma, and which were then expelled at the same time as the magma.
It's until 18 hours after the start of the eruption that Pompeii and its inhabitants are afforded some respite. Gradually, the survivors leave their shelters and attempt to leave the city. It would be a grueling journey.
Moving around the city became difficult, both because it was impossible to recognize the roads one normally took, which were buried under pumice stone, but also because the lapilli deposits were very unstable, and so those trying to escape easily sank into them like quicksand.
What these fugitives didn't know was that the volcano was entering its most dangerous phase. At the quarry, a radical change in the elements being ejected by Vesuvius shows us that at this stage, the eruption was undergoing a dramatic transformation.
What was happening was that such a large amount of magma had been ejected, several cubic kilometers, that the central part of the volcano, the summit, collapsed, producing big fragments, which were displaced by the pyroclastic current, and which we can see in the upper part of this cross-section. We can see these big blocks of lava, which represent the climax of the eruption. It's the point at which the most energy is emitted. The pyroclastic current made its way to Pompeii and destroyed everything in its path.
Pliny bears witness to this phase in his texts.
A black and dreadful cloud broken with rapid zigzag flashes revealed behind it variously shaped masses of flame, like sheet lightning.
The survivors in Pompeii hear the current speeding down the slopes of the volcano and turn to look. it's hurtling towards them at 200 kilometers per hour. Within less than a minute, the current reaches the city, leaving nothing but a layer of deathly ash in its wake.
These deposits signify a pyroclastic current that swept through the city of Pompeii, destroying everything above the layer of pumice stone.
The current's unprecedented power transformed Pompeii forever, leaving 650 victims inside a tomb of ash.
Everyone who survived until the morning on the second day was then killed by this pyroclastic current, whether they were inside their houses or outside on the street.
These 13 bodies are those of a group of people trying to escape the lapilli that were falling on the city. In this case, for example, in the child's hand, the folds of the material of the clothes he was wearing when he died have been preserved.
How have these incredibly detailed figures survived nearly 2,000 years of history? We owe their impressive level of preservation to Giuseppe Fiorelli, head of excavations in the 1860s. When he discovered that the hardened ash from the volcano covering the city had preserved the imprint of the victims' bodies, he used an extremely innovative method to preserve them.
When Fiorelli found these pockets of void, he didn't destroy them to try and find skeletons. Instead, he pierced a hole through which he poured liquid plaster, recreating the bodies of these Pompeians.
Perhaps even more surprising is that this technique is still used today. Although it's clear that the extreme heat was the cause of death in Herculaneum, scientific opinion varies where the bodies discovered in Pompeii are concerned.
Some researchers have interpreted the position of the molds to be those of bent arms and legs, known in technical jargon as a pugilistic attitude, proof of death from extreme heat, which would lead to contraction of the muscles due to being exposed to such high temperatures. In reality, we have also discovered people in exactly the same position, but who almost certainly died from asphyxiation because their throats were filled with ash, and they were trying to protect their mouths with pieces of cloth. Research is ongoing in collaboration with volcanologists, forensic scientists, anthropologists, chemists, and we hope to improve our understanding of the site in the future.
5 minutes after it started cascading down the slopes of the volcano, the pyroclastic current continued to advance, even rolling over the surface of the water.
The cloud began to descend and cover the sea. It had already surrounded and concealed the island of Capri. This pyroclastic flow is the one that covered the greatest distance. It traveled more than 25 kilometers from Vesuvius, and over there we can see the Lattari Mountains, which rise up more than a kilometer and a half. And on these mountains we found exactly the same ash, at an altitude of 800 meters above sea level.
Even the western part of the bay where Pliny was about to be submerged.
I turned my head and saw behind us a thick smoke following us, spreading itself over the land like a torrent.
According to research, this part of the burning cloud which Pliny saw was not lethal.
During this most devastating pyroclastic current that went towards south, a part of this current, the most diluted one, was not energetic at all, but just came as a dark cloud in which Pliny the Younger found himself.
It was like being in a room in which all the lights had been put out. You could hear nothing but the moans of the women, the wailing of children, and the cries of men.
After around 20 hours, the eruption began to subside. Pompeii, Herculaneum, and several other places near the volcano had been erased from the map. Pliny was alive.
Soon after, the day returned, the sun shining with a lurid light. Like during an eclipse, everything seemed changed and was covered deep with ashes, as if with snow.
Today, we can offer a better estimation of the incredible power discharged by the volcano in under 24 hours.
At the end of the eruption, we have an estimation of 3-4 cubic kilometer of material emitted in total. And probably this is, again, is a minimum estimation.
The area covered by the deposits is thousands of square kilometers. All of these parameters tell us we're talking about a really enormous eruption.
Despite centuries of research and archaeological digs, it's still difficult today to estimate the number of lives lost in the disaster. Around 1,800 bodies have been found in Pompeii, Herculaneum, and several other locations nearby. But hundreds, even thousands, will probably remain forever buried in the ashes. But one thing is certain: the number of victims is much lower than once believed.
Archaeological evidence demonstrates that the majority of the city had been evacuated. Where did these people escape to? Historical and archaeological studies have recently come up with a list of surnames of families originally from Pompeii and Herculaneum, Puteoli and Neapolis. So at the start of the eruption, lots of these people fled towards Naples, then Pozzuoli, and they survived.
Paradoxically, this eruption, so tragic for those alive at the time, has left an unimaginably rich heritage for future generations.
The unique characteristics of these archaeological sites stems from the fact that everything has been perfectly preserved. We have constructions, houses, public buildings, but also the victims and their possessions and any food they were carrying with them. All of it perfectly preserved. So we have pieces of bread, the remains of fruit, which have been perfectly preserved thanks to a very specific process of very rapid carbonization and burial under volcanic deposits. If we hadn't had this moment where everything became frozen in time, we wouldn't have this sort of Sistine Chapel before us now. It's amazing.
The eruption is also still an extremely precious source of information for volcanologists observing the volcano today. Because life continues around the slopes of Vesuvius, and despite its apparent inactivity, it is still a very real danger for Naples and the surrounding areas.
When you look at Vesuvius's past, the eruptions take place every several thousand years. So we know there will be others. It's inevitable. It's part of the volcano's history. There's something like 4 million, 4.5 million people living in the area around Vesuvius. That means that one day they will experience an eruption. There's no doubt that Vesuvius is an active volcano. There are gas emissions and earthquakes. Unfortunately, right now, it's impossible to know what a future eruption might look like, and even less so when it might happen. So to try and protect ourselves from the volcano, a particularly intensive observation program has been put in place. In some ways, we can use Pompeii as a research lab. Every time we find new ruins, we can work out exactly which phase of the eruption caused them, and therefore know that in the future, if we have an eruption that goes through the same phases, we can assume that there will be the same type of consequences.
Innumerable amounts of data collected from the site also allow scientists to continuously improve their simulations.
You can observe the deposit, and then by comparing the observation with the simulation, you can estimate your ability in reproducing a certain kind of phenomena. The 79 Vesuvius eruption is incredible because we have a lot of data, and is a huge eruption and that are not so often seen on the Earth.
Digital models allow us to have a much more precise idea of the terrible threat looming over the area and its inhabitants.
In this particular simulation, for example, we can see the effect of pyroclastic density currents generated by a mid-sized volcanic eruption at Vesuvius on Naples, and the fact that they channelize and they can go in the direction of specific places around the volcano. We can say, for example, the speed of the pyroclastic density currents, the dynamic pressure that these flows are able to give on the walls of the buildings, and the temperature.
To protect us from the risks associated with a volcano, we have to study that volcano. We have the history of this volcano. We know what has happened in the past. We're aware of the tragic consequences to the population. So based on those models, we can try to organize evacuation plans. We can also educate the population to react as quickly as possible, to get used to living with the risk, and above all, how to react to it. Where should they go? Using what types of transport? The goal is to be able to react as quickly as possible and to manage the very large populations living around Vesuvius today.
This in-depth work by physicists, volcanologists, and archaeologists is more important today than ever before, so that a new Pompeii disaster with even more catastrophic consequences cannot take place today.